that mean an error did not occur for sure? No. When could an error have occurred? Under what circumstances here? What properties would E have to have? Well, for one thing, C plus E has to be a valid code word in that case. So what properties would E have to have if this is a linear block code? It would itself have to be a code word. So undetectable errors occur if E is in the code. So if E is in the code, E plus C is a valid code word, which means that if I multiply on the left by a valid code word, I get the all zero code vector. So then I report there is no error, even though an error has occurred. So that's called an undetectable error. Okay, how do we correct errors with this property? Error correction. In particular, think about single error correction. By the way, so what do I mean by this? So y equals C plus E. This is mod 2. So what this means is that if EI equals 0, then CI, then, excuse me, if EI equals 0, then YI equals CI. In other words, no error occurs in that position. If EI equals 1, then YI is not equal to CI. In other words, an error does occur in that position. So therefore, the number of errors is the Hamming weight of the error sequence. So now I'm going to say I'm only interested in single error correction. So here, I'm going to assume the Hamming weight of the error sequence is equal to 1. So furthermore, let's say at the detector, or at the decoder, here's what I do. I take Y and I multiply by H transpose, and that gives me the result S. We already know that if S is equal to all 0, that Y is a valid code word. So the natural assumption is that that code word is correct, so we take no further action. If S is non-zero, what does that mean? Well, Y is equal to C plus E, so Y H transpose is equal to C plus E H transpose, which is, I can, again, all the usual arithmetic applies here, so that's equal to C H transpose plus E H transpose. What's this? That's a code word multiplied by Brady check matrix, so it's 0. So this is E H transpose. So let's think a little bit about H transpose. H is an n minus k by n matrix. So H transpose, I basically flip the dimensions. H transpose is an n by n minus k, n rows, n minus k columns. And E is a 1 by n vector. So we have E1, E2, and so on, up to En times H transpose, which is, I'm going to write the rows of H transpose as H, little h1, little h2, so these are rows, little h3, and so on, up to little hn. Now remember, by assumption, the Hamming weight of the error sequence is 1. So there will be some I, so that EI is equal to 1, and all other EJ is equal to 0. So if that's true, then E1, E2, so on up to EI, so on up to, actually let's do this, EI minus 1, EI, EI plus 1, so on up to EN would be equal to this. Everything is 0 except EI, so it's 0, 0, 1, 0, 0. So the error occurs in the ith position. What does that mean over here? If I take this, so 0, if EI is 1, EH transpose is equal to what? Well, it's E1 times H1 plus E2 times H2. So basically, EH transpose is the sum from I equals 1 to n. Let's use J. The sum from J equals 1 to n of EJ, HJ. But if they're all equal to 0, except EI, then this necessarily equals EI, HI. So, bearing this in mind, how would I figure out where the error happened? So I have, well actually it's better to say this. EI is 1, so therefore this is equal to HI. So how would I figure out where the error happened?
Whichever row is not 0.
Whichever row is...
H is not 0.
So I have HI,
Yeah.
so I compare that to the rows here.
Yeah.
Once I find HI, once I find the row that matches this, that's where my error must have occurred.
Can the HI's value take anything, like it should be 1, right, in this case?
So it's HI is actually a vector.
Oh, I see, okay, so HI,
So this is a 1 by n minus k vector. So this gives us an idea of how to design a single error-corrected code. So let all rows of H transpose be unique. In other words, all the rows of H transpose are different. Then we will always be able to pick off which row that HI will correspond to a unique row in H transpose, and we'll always be able to pick off that row. So this should be a single error correcting code. So let's try that. Oh, important to point out the following. If this is all 0, that's our flag to indicate that no error happened. So there's one possibility here that is not allowed, and that is that there's one possibility for the unique rows that's not allowed, and that's all 0.